Okay, so our last shape we're going to do of the volume of is the volume of a sphere. And a sphere looks like this. It's like a big round ball, right? And if I'm going to draw a sphere, the best way to draw it is to draw the circle. And then we're going to give it the dimension, like the look of the 3D, by drawing a forward curve and then the back curve that we wouldn't be able to see. That's why it's dotted. So we are going to give you the equation for the sphere, and typically I would develop this with you, but it depends on the surface area of a sphere, and we ended up not being able to do the surface area part of this unit. So I'm just going to give you this volume formula, which is 4 times the radius cubed times pi, all divided by 3. So let's take a look at an example. This one asks us to find the volume of a sphere with a diameter of 10. So if I put my formula for the volume of a sphere, I notice that the variable that I'm substituting in for is radius, but we were given diameter. So I have to find out that my radius is half of that diameter. And then I can substitute into the formula. So I'm going to get 4 times the radius cubed over times pi divided by 3. Now notice it's asking me for both exact and approximate. So approximate, I would take this entire thing, type it into my calculator, and get a decimal, and I would round to the nearest tenth. So if I do that, I get 523.6 centimeters cubed. But if I want to get the exact value, I am going to only type in this part, and I'm going to then hit the math button on my calculator, and then there's something that says FRAC for fraction, and that is going to help me keep this in exact terms. So that is 500 thirds, but I need to make sure I remember my pi. I don't want to forget it. But by not typing the pi in, it allows us to get an exact value of our fraction. Okay, so exact and approximate. So this time you're going to try. Find the volume of a sphere that has a radius of 12 feet. Notice right here where it says exact volume. So make sure to pay attention to that and give this one a try. All right, so now we are going to find the volume, the exact volume of a hemisphere. So a hemisphere, like if I draw a sphere, this is my sphere right here, right? That's my sphere. If I wanted to draw my hemisphere, I might actually just use this drawing because it's not so bad. And then I would get rid of half of the sphere, right? I would just leave the top or the bottom. I'm going to leave the top half of the sphere. And so now it is half of a sphere, right? That is my hemisphere. So I'm going to start by finding the volume of the sphere, which is going to be 4 times the radius, which we know is 8, cubed times pi divided by 3. That would be my volume of a sphere. However, it asks us for the volume of the hemisphere. So what we want to do is we want to really take that and we want to divide that whole thing by 2. So it might be easier to think of this as multiplying by a half, because then it's a little easier to see that this will become 4 times 8 cubed times pi divided by 6. Okay, so when we're finding the hemisphere, we have to make sure we're accounting for the fact that we only want half of that sphere formula. Okay, now it asks us for the exact volume, so I am going to type that into my calculator, but I'm only going to type this part again, and that is going to give me 1024 pi over 3, and my units would be meters cubed. So So I want you to try this one. Find the volume of a hemisphere that has a diameter of 6 centimeters. This time you are rounding to the nearest tenth. All right, let's take a look at this reasoning question. And before I talk about it, I'd actually like you to read this and predict. Basically, I'm wondering, is it true that diagram 1 would have a greater volume than diagram 2? So give you a second to read and think about what you think about that. Okay, so it tells us that diagram 1 and diagram 2 are both made up of a hemisphere and a cylinder. And it says the heights and the radii are congruent. So this statement is saying, is the diagram 1 larger than the diagram 2? But what we know is that the heights are the same. We know the radii here are the same and the radii here are the same. So it's made up of all of the same parts. So really, this statement is not true, because whether I have these two pieces separate from each other or the same two pieces attached to each other, it's going to give us the same exact volume, right? And so that's actually a useful strategy. If you're finding the volume of stacked solids, it's very helpful to divide it into two parts and find the volume separately and then just add them up. Okay, let's take a look at this example. This is one of my favorite ones to think about. So this one tells us that we're thinking about this box that has 3 golf balls in it, and they fit snugly. And so you can assume that if you have the the rectangular prism, that the edge of the ball is touching all 4 sides of this rectangular prism. So it's fitting very snugly. Okay? So what we are going to do now is our goal is to figure out basically the volume of the leftover space. So if I'm going to find the leftover space, I need to find the volume of the rectangular prism, and I need to take away the volume of the golf ball. But there's not just one golf ball, there's 3 golf balls. So my plan is to find the volume of the prism and then take away 3 of the volume of a single golf ball. So the volume of a prism, we have to think about what is this going to really look like, okay? It says the diameter of the ball is 2 centimeters. So if I draw that, let me see if I can find a different color that shows up a little better. If I draw that here, right, and this is 2 centimeters, well, that diameter is the same all the way around. So that means that the base of this prism is 2 centimeters, and it must be a square prism, right? A square-based prism, because then this depth of the prism is also going to be 2 centimeters. Okay? Now, I need to figure out the height, and there's 3 golf balls. So there's a diameter of 2 for the first golf ball, a diameter of 2 for the second golf ball, and a diameter of 2 for the third golf ball. So total, that gives me a height of 6. So to find my volume of the prism, I'm going to take the area of the base times the height. The area of my square base, right, is going to be 2 times 2, which is 4, because that's my base. My height is 6, so my volume of a prism is 24. Okay? Now I also want to find the volume of a single golf ball, which is the shape of a sphere. So if the diameter is 2, that makes the radius only half of that, right? It would be the radius is equal to 1. Okay, now I know that my volume formula for a sphere, I should call this for golf ball because that's what I called it before, is going to be 4 times the radius cubed, so 1 cubed times pi divided by 3, which gives me 4 pi over 3. So that's not my volume of my golf ball. So now what I really would like to do is find the leftover space. So I'm going to remove the golf balls from the prism. So my prism is 24. I want to subtract 3 of my golf balls, and each golf ball is 4 pi over 3. So nicely, these 3's actually go ahead and cancel out, and I get 24 minus 4 pi centimeters cubed. However, this actually asks us for the approximate volume, so that rounded to the nearest tenth. So when I do that, I get, and actually this is a rounded value, so that's approximately 11.4 centimeters cubed. So remember, anytime you're finding these composite volumes where you have multiple things going on, it's important to ask yourself, am I going to add 2 parts? Am I going to subtract 2 parts? How am I going to strategize to get the volume that I'm trying to find? Okay. Now it's your turn, and this is the last problem of the day. I'd like you to find the volume, not the surface area. That was a typo right there, just volume. The volume of the stacked hemisphere on the cylinder. Okay, so you're not doing surface area, you're just doing volume. And let's go ahead and have you round to the nearest tenth. All right, give that one a try.